So, hello everyone, and today we'll try and cover all the rest over topics of the basic series in network theory. So far, we have done mesh analysis, nodal analysis, parallel and series combination, star and delta combination, uh, uh, and other such related topics. Today we'll try and cover balanced bridges, and we'll also try and cover in case we do have time, we'll try and cover topics in questions related to infinite resistance questions. I think we are all aware that in your exams you do find questions of this sort, this formation, something of this sort. I'm just drawing it in rough for you here. Something which continues to infinite, something of this sort. So these are like infinite series questions on resistance. These are some other questions that we'll be doing. We'll try and finish today, if time allows. Okay. Okay. So beginning with questions on balanced bridges. I hope we are all clear with what is a balanced bridge. Okay. So what do you understand? What do you understand by a balanced bridge? Let's say there's a galvanometer here in this circuit. When will the bridge be called a balanced bridge? When will the bridge be called a balanced bridge? It is here in this circuit. Can I say, can I say when this point and this point and this point are equipotential, when point A and B are equipotential, there shall be no current flowing through this branch, right? What is the minimum requirement of a current flowing through a circuit? There should be a potential difference, right? In any branch, when will a current flow? When there is a potential difference. What if the potential difference reduces to zero? If VA and VB are at same potential. So can I write VA minus VB would be equal to what? Zero, right? So what is the condition? What is the condition for such an event? For such an event, R1 upon R2 should be equal to what? R3 upon R4. This is the condition of balanced bridge. In short, a bridge is said to be balanced when in such a structure, point A and point B are equipotential. That is what we need to keep in mind. Okay. Now, try solving this question given to you in the figure. Okay, look closely and tell me, do you see any bridge kind of structure in this question? Do you see any bridge kind of structure in this question? See, let's just break it down to easier parts, and then you will realize how this structure, as of now, we don't see any bridge kind of structure, right? At this point, when we cannot say if this is a balanced bridge or not a balanced bridge or whatever. We cannot make any statement as of now. But tell me, can I reduce this 10 parallel 10? It is the question is asking you what? The current in this branch, right? If you had no idea if it is balanced bridge or not a balanced bridge, what would you have done? You would have solved step by step, right? See, you cannot say about any other resistance uh, whether it is a series or parallel, but for these two resistances, when we can clearly say what, that these are what, in parallel, right? These two branches are what, in parallel. Can I say it, right? So if I reduce this and this, what is 10 parallel to 10? What did we learn? If two resistances of equal magnitude are in parallel, what is the resultant are equivalent? Or let us say if n resistors are in parallel, what is the equivalent resistance? R by N. So in this case, R is what? There are two resistances in parallel, so N is 2, the resistance is 10, so it makes it 5, right? Can I do it? Right? So let us reduce these two to 5. I'll redraw the circuit for you and look closely. And from here, we'll redraw our circuit and how we'll understand how this circuit now becomes a case of balanced bridge. Look closely. This is what, 5 ohm, because I've reduced these two resistances to what? These two resistances to these are parallel to to each other. Now look closely. Excuse me for my drawing, because I'm trying to save time here. So I'm not using the straight line feature of this application, because that will consume a lot of time. Okay. So this is your resultant network. Now, again, I am just redrawing this circuit to show you how such a circuit would again converge to a bridge configuration. Look closely. I am naming this node to be what? A. Let us name this one to be B, this one to be C, and this one to be D. Okay. Now, between A and B, I see a resistance. Let us say, let A be here. Let us say, take B to be here. Between A and B, I see a resistance. And the value of resistance is what? 5 ohm. Right? Now, between A and C, I again see a resistor. So let me name this to be here. This is our point from which we started. Between A and C, there is again what? A resistor. What is the value here this time again? 5 ohms. Right? Now, between B and C, if you see, between B and C, I see a resistance. Yes, there is. What is the value of such resistance? It is 10 ohm. Right? Now, I did not consider point D. Let us take point D here in this case. Now, tell me, Between B and D, between B and D, is there a resistance? Yes. What is the value of such resistance? It is 15 ohms. And between C and D, yes, there is 15 ohms. Now, from point D of the circuit, I see a source, the negative potential of the source, right? And the source value is 20 volts. And from A, I see a 10 ohm resistor which eventually connects to the positive terminal of the battery, right? The question still demands the value of I. Now, what the structure which appeared to be like this, and we assume that it is not solvable, or probably we will have to use what? We will have to use star delta transformation. But now, do you realize how easy this question becomes by simply what? Network redrawing technique, right? So simply by network redrawing, we realize this circuit is a balanced bridge, and in balanced bridge, we know when R1 upon R2 is equals to R3 upon R4, there will be no current flowing in the branch, this BC, right? There will be no current flowing in this branch. So can I remove this branch, right? So what would our equivalent circuit be? I'm erasing this part of the board. Okay. Let me erase this part of the board. Okay. I hope you noted down everything that I was talking. Okay. So does our network reduce to, again using the same nomenclature of nodes? Tell me, this node is absent now. This node is absent. This is 5, this is 15. 5 and 15, if this is not there, 5 and 15 would be in series. 5 plus 15 becomes 20 ohms. Similarly, 5 plus 15 becomes 20 ohms. So, can I make this network to be something of this sort? Right? This would be 20, this would be 20, and from here we'll have 10 ohms connected to a 20-volt battery. I'm again saying, pardon my drawing in this case. I do realize the network should not be drawn in such a way, but I'm just trying to save time. Okay. So this is 20 volt. Now 20 parallel 20 is 10, right? The same logic here. 20 parallel 20 would be 10. So this makes 10. So this equivalent would be what? 10, which is again in series with 10 ohm resistor. This is again 10 ohm resistor and the equivalent 20 volt. So your question, the answer to your question is 20 volt divided by 20 ohms is equals to I is equals to 1 ampere. I hope it is clear, right? I hope it's clear. If you have any doubts, please post it in the live chat. At any point, if there's any doubt, please post it on the live chat. Okay. Can I move to the next question? Okay. Try attempting this question and tell me. It's just a. Okay, observe the question and tell me how to solve this question. The question asks you I, the I is here. Everything else is given to you in the network. How would you approach the question? Okay, I'll solve this for you. What do you see in this network? Again, 6 parallel to 3, 6 parallel to 3. No current will flow in this branch, right? Right? Similarly, no current will flow in this branch because it is what? A balanced bridge structure. And if it is a balanced bridge structure, these two branches will eventually have no current flowing through them. So the circuit will eventually reduce to, it's a very easy question, okay? And all it otherwise, in case you were not familiar with the concept of a balanced bridge, you would have solved it using star delta transformation, and that would have consumed a hell lot of time and it would have very clumsy calculations. So this is the first thing that you'll observe in questions where you find such approach is applicable. You will see if the bridge is balanced or not. In case the bridge is not balanced, you will have to approach the question by star delta transformations. Okay, it only makes the question a little more clumsy and it will require you to make absolutely no silly mistake. Only then you will get to your answer in case you skip such trick. It's not even a trick, it's a actual fact, right? Tell me what is the equivalent. If 9 ohm is absent from the circuit, can I write R equivalent for this network? R equivalent for this network would be what? 2 plus 2 plus 2 is 2 plus 2 is 4. It is in series, right? 4 in parallel to 3 plus 3 is 6 in parallel to 6 plus 6 is 12. This would be your R equivalent and your current I would be equal to what? 24 upon R equivalent. Right? Do you want me to solve this for you? Or you can do it on your own? Okay, let me do it for you. 1 upon R equivalent is equals to 1 by 12 plus 1 by 6 plus 1 by 4. Can I write it? Right? Can I write 12 upon R equivalent is equals to 1 plus 12. I am multiplying 12 on both sides, okay? So 12 by 6 is what? 2, is it? 12, I am multiplying 12 by both sides, okay? Right? So can I write 12 upon R equivalent is equals to 6. R equivalent is equals to 2. Right? It's not R equivalent. R equivalent is 2 plus this. Let us call this one as, give me a second. Let us call this one as R dash, okay? Okay. So let us call this one as R dash. R dash, R dash, R dash. Okay. So R dash becomes 2 ohms. Okay. So R equivalent is 2 plus R dash, which is eventually equal to 2 plus 2 is equals to 4. So I will become 24 divided by 4 is equals to what? 6 amperes, your answer. Right? So far any problem? Any doubt? Okay. This one is a little trickier from whatever we have done in the past. The question says, the bridge is balanced. The question says the bridge is balanced. We have to find the source current. I have not written IS here. We have to find the source current IS. Now, in this question, how are you going to approach the question? You have been already provided with you are already given with the fact that the bridge is what? Balanced. So if the bridge is balanced, what are the few things that you know? First thing that we know is the resistance would be in the same ratio. The ratio of resistance would be same. But this time you are not given with any resistance here. Right? If you're not given with any resistance here, the second thing that you know is if the bridge is balanced, there will be no current flowing between A and B. Why is it that there are no current flows between A and B? No current flows between A and B because A and B are at same potential, right? That we can use, right? So let me, for the sake of solving, mark this point to be as ground. If I mark this point to be ground, tell me what is the absolute potential of point A with respect to ground. What is it? If this is plus 2, so this should be what? If this is 0 and this is plus 2 volt, so this must have been minus 2 only, then this potential is 2 times higher. So can I say the absolute potential of point A with respect to ground is equal to minus 2 volt? But because the bridge is balanced, does that not also give me the information that VBO equals to what? VBO also equals to minus 2 volt. Is it correct? Right? If it is minus 2, can can I can I can I say this is point C, this is point B, right? The potential between point C and B is given to be what? It is already given to you as it is all, the potential between point C and B. I am talking about what? I am talking about this branch, right? So it is already VCB. VCB is already given to you as 9 volt, right? If it is 9 volts, can I say because the bridge is balanced and A and B are what? Equipotential. A and B are equipotential. If they are equipotential, so V minus, see what is VCB? VCB is what? Tell me. VCB is equals to what? VC minus VB, right? And VCA would be what? VC minus VA. But what did we deduce? We deduced that VA and VB are same and they are equal to minus 2 volts. right? So can I say VCA is equals to 9 volt? Am I making sense? See, VCB is given to you by figure as 9 volts. VC minus VB is equals to what? 9 volts. I am replacing VB with VA is equals to 9 volt. How? How can I do that? Because VB and VA we derived in our step before this that both of them are what? Equal and equal to what magnitude? Minus 2. So they are equal. So can I say VCB is equals to 9 volts? VCA is equals to 9 volts? Does, does that make sense? Right? Can I say that? Can I say that? Now, also look closely. Also look closely. Because the bridges balance, there will be no current in this branch. Right? So whatever is the current, there will be two branches of current, one through this and one through this, which will eventually converge here. So the source IS will be supplying two branches, one to this branch and the other to this branch. Can I calculate when I am given the potential between these two? When I am given the potential between these 2 points and the resistance, can I calculate the current in this branch? Can I do that? So let us calculate the current in this 3 kilo ohm resistor. VCA upon 3 kilo ohm is equal to what? The current in that branch, VCA is 9, it is 3 kilo ohm. So the current reduces to, comes out to be what? 3 milliamperes. This is current in one branch, right? Now, similarly, I am given the potential between these two branches and I have the resistance here. Can I write the second current VBO upon 1 kilo ohm is equals to 1 milliampere, right? This will be 2. But IS, the source current IS is equals to what? The source current Is is equals to 1 plus 2. That is what we saw. There is no current flowing in this branch. So this will be what? The total current supplied by the source will divide into two branches. One here, one here. This one is the current in the 3 kilo ohm resistor. This current would be the current in 1 kilo ohm resistor, which we have calculated. So the total current is 3 plus 1 is equals to 4 milliamperes. That would be your answer. It was a very simple question. All you need to do is step by step. Did I make some mistake? Yes, I did. Yes, I did. And nobody corrected me also. See, the current that we took from the source is in this direction. But the potential in this case was what? Minus 2. Right? It was what? Minus 2. It was not 1. Why did I take it to be 1? That is my mistake. Let me just correct it. VBO is calculated to be minus 2 volts. It was given to you in the question. Yes, VBO is minus 2 and the resistance is 1 kilo ohm. So your answer will be minus 2 milliamperes. Right? And if you make do the sum of these two, it will not be 4. It will be 3 minus 2 is equals to 1 milliampere. That was your answer. Okay? Okay? Does that make sense? As of now, do you have any doubts? All we have done so far are questions based on balanced bridges. And if you ask me truthfully, this was the first question which I find is worth your brain. Before this, everything was cakewalk. All you need to do is focus on network redrawing technique. Everything was cakewalk as of now. This is something which engages your brain and also to not to a level which you cannot solve. It's a simple question. That is why we are covering our series on what? Basics as of now. We haven't reached theorems. Soon we'll try and cover network theorems like Thevenin and Norton. We'll soon try and cover those. But I need you to be, very acquainted to such basics. Only then you can do easy, you can, make progress in theorems. Theorems are very easy. They are simple application of whatever you've learned so far. Okay? Okay. Another easy question. Tell me how to do it. It is already given to you that the bridge is balanced. How will you approach the question? Very easy. Tell me. If the bridge is balanced, what will be the value of C3? Very easy question. What did we learn? In a balanced bridge, Z1 upon Z2 is equals to Z3 upon Z4. Z1 is given to you as 1 kilo ohm. Z2 is given to you as 3 kilo ohm. What is the impedance in case of capacitance? It is 1 upon j omega C3 upon 1 upon j omega. What is the value of C3? 35 picofarads. It is given to you, right? So can I write 1 by 3 is equals to 35 picofarad upon C3, or C3 is equals to 105 picofarad. Very easy question. All you needed to remember was impedance of a capacitor is 1 upon j omega C. This is what you need to remember. And I think I have on purpose included a lot of question based on capacitances just so that you don't make this silly error. What generally people do is they replace this impedance by the capacitance itself, but it will not be true. It will not be true. Why? Because in case of capacitance, the impedance is in inverse ratio to the capacitance. So there is no direct relation. So you need to make sure that do not make this mistake. It's a very easy question. There will be no current flowing through the galvanometer. It is a balanced bridge. It is given to you in the question. So, the ratio of impedances will be same on both left and right side. Is it clear? Is it clear? Moving on. Okay. So, this is something. Let me just see if there's any other. Yes, okay. So, there's one more bridge question, and tell me how do you solve it. Easy? How do you solve this question? Look at the question carefully. What does the question state? You can always stop me wherever you find that the speed is of solving questions is faster, in case you're writing it down, because writing would take time. In case you're just hearing, it's not difficult. Also, the topic is very easy, so I won't recommend a lot of, learn here right now. That is it. Focus on learning. Do questions on your own also, because I can do only a few questions for you which I find interesting, which I find engaging. But a lot of questions that only when you practice you will understand which question to approach how, right? Tell me, would there be any difference? Okay. If the switch closes, this resistance would come in play. If this resistance would come in play, there should be, by simple logic, there should be some change in the intensity of the lamp. But I'm telling you the answer. Explain. There will be no change in the intensity. Why? As it is, when the switch was open, there was no current flowing in this loop. Even when you close the loop, this is okay. Uh, this is connected. Okay. Even when you close the loop, you will realize the network is balanced and the bridge is balanced, so there will be no current flowing again. So the condition prior to switching in and the condition after that remains unchanged, and so the intensity will also remain unchanged. Easy question. Do you have any doubts as of now? Okay, so far we have done all the questions based on what? We have done 4 questions as of now, all based on balanced bridges. Rather, I think we've done 5 questions, whatever. So the number is not important. The point is we have done whatever the number of questions we've done so far, they were based on what? Balanced bridges. Next we'll be doing questions based on simple common sense. I am repeating it, simple common sense. But these are questions which would open your mind, which will allow you to think in a different way, approach a question in a different way. Now look closely. The question asks you the potential in this 15 ohm resistor. The potential in this 15 ohm resistor. What is given to you? There is a network N1, there is a network N2. There are 3 branches of resistors connecting it. One of them is 5 ohm resistor which sees a 10-volt drop. Similarly, there's a 1 ohm resistor which sees what? 5 ohm 5 volt drop here. Remember this 15 ohm resistor is has unknown potential. Okay, I hope I know the drawing is a little bit clumsy. Let me try and improve this for you so that there remains no confusion. I am writing it right here, 5 volt comma 1 ohm. Similarly, this is the 15 ohm resistor. This is your 15 ohm resistor and the potential across it is not known. The polarity though is given to you. Now tell me how are you going to proceed? Okay, so you're given with polarity in each resistor, right? Can you determine the direction of current in each case? What have we learned? What have we learned? We learned that wherever we see a in resistor, in resistor, wherever we see, wherever we see that there is a plus sign, which means the current is wherever we see a plus sign, we see the current is in that direction, right? Plus to minus. So there will be current in this direction, there will be current in this direction. You are already given with polarity in this case, so you will have to assume a current in this direction, right? Right? Now tell me, what I am just, I know nothing about this question. I don't know how to approach it, but all I know is we are given with some values and I can find out whatever I can find out with these values, I will find out, right? So tell me, what is the current in 5 ohm branch and in which direction? This is a 10 volt drop, this is a 5 ohm resistor. What will be the current? 10 divided by 5 is what? 2 amperes. What is the direction from N1 to N2? This is the first thing I derived. See, I know nothing. All I know. Whatever I can find out with whatever I am given so far, I will find out. See, that is the approach I am using. I know absolutely nothing. Okay. Now tell me, what is the current in 1 ohm resistor? Can I write? 5 is the voltage drop, 1 is the resistance, so there will be 5 ampere current flowing. There will be 5 ampere current flowing from N1 to N2. Clear cut values. Now, now, if you see, if you see, there are only 3 branches which are connecting network N1 and N2. These two branches, we can say for sure, are carrying current from N1 to N2, right? So, as a principle, we know that current flows in a loop. So, if two branches are taking the current from N1 to N2, there is no, if we see, there is, so far there is no branch. So far from whatever we have calculated, no branch takes the current from N2 to N1. But this cannot be the case, right? That cannot be a case. So, one thing that we have deduced is the current in 15 ohm branch should be N2 to N1. Why? Because two are taking the currents from N1 to N2. So there should be one which is taking it from, at least one. Taking it from what? Because current flows in a complete loop. There cannot be simply two branches taking current and no current return, no branch taking it away, because it should be a loop. So one thing that we have deduced so far is the current in 15 ohm branch would be from N2 to N1. One point is clear, right? Now what will be this current? If 2 flows from here, 5 flows from here, so effective what? I1 ohm plus I5 ohm is equals to what? 7 amperes N1 to N2. So, what should be from N2 to N1? 7 amperes should be returning, right? If 7 amperes is going from N1 to N2, 7 amperes should also be returning from N2 to N1, but there is only one branch which is returning, so current in 15 ohm branch would be what? Current from N2 to N1, that would be 15 ohm, that would be 7 amperes in this direction, right? Now tell me, what will be the potential? So the current we have by by so far we found out that the current actually flows from N2 to N1. So what would be V of 15 ohm, which is equal to what? It is equal to minus V. What have we been asked? We have been asked V like this, but the polarity is plus minus. When the actual polarity is what? Here plus, here minus. So it is opposite of asked to you in the question. So V 15 ohms is equals to minus V is equal to what? Is equals to 7 into 7 is the current flowing, 15 ohm is the resistance, is equals to what? Tell me. 105 volts, or can I say V is equals to minus 105 volts? Was an easy question, right? Wasn't it easy? Do you have any doubt? Priyadarshini, from like mm, tomorrow also we'll try and take, miscellaneous questions. Okay. Tomorrow also we'll take miscellaneous questions. I'll try and I did tell you I'll try and finish off this basics because I think it's stretching a lot. And also I need to, rush with your course. At this speed, we will never reach what we are intending to. So tomorrow also we'll have a class on basics and I'll try and take as many numericals as I can think of. Okay? We are done with equipotential nodes. Yes, we are done with equipotential nodes. So tomorrow we'll have more or less more numericals only. Okay? Okay. So in our next question, and this probably would be the last for our day. Tell me Tell me, you are okay. Look closely in what is given to you. It is given that the potential difference between point A and B is what 6 volts, and it is asking you the potential difference between C and D. You are given with potential difference between point A and point B, and it is asking you the potential difference between point C and point D. Right? Now tell me, how are you going to approach the network? Okay, look closely and see, do you see any similarity between this network and this network? This network and this network, do you see any similarity? Do you see the concept of return path? What did we utilize in this question? The concept of return path, right? So if two branches are taking current from N1 and to N2, there should be some return path and it will carry what? It will carry an equal amount of current in return, right? That is what we exploited. This is the fact that we exploited and we found out our answer. Can you use a similar analogy in this network? See, I want you to be, eventually I want you to be able to think such things. Right now, I am giving you answers to every question as it is, but I want you to be able to, realize just the second that you are given this question. I want you to realize how are you going to, approach this question. That is why I keep saying practice. Okay, I'll solve this for you. VA minus VB is given to you as 6 volts. I told you to draw analogy. Let us Take this one to be N1, this one to be N2. See, even if you did not know what are the R's here given, you did not want to, you did not have to reduce this down. You could have seen the question and said what? That it is insufficient data, right? You would have concluded that it is insufficient data, but it is not insufficient. Look closely, all you need to do is exploit the fact that every current would require a return path. So if this is network 1, this is network 2, you are given with potential between point A and B. Can you find out the current in this branch? Can you find out the current in this branch? Tell me what will be current IA to B. The value, the potential VAB upon the resistance RAB, right? What is the value of VAB? It is given to you as 6 volts. What is the value of RAB? It is given to you as 2 ohms. So your current comes out to be what? 3 amperes. A 3 ampere current flows from A to B. A 3 ampere current is flowing from network N1 to network N2. But the current is not returning. So that cannot be true, right? So if there is a current 3 amperes going from A to B, there should be a current 3 amperes of same magnitude flowing from what? N2 to N1. So can I say IDC? IDC. Can I say IDC is equal to what? IDC is equal to what? IDC would be equal to 3 amperes. Can I say that? Can I say that without, you know, any doubt? See, it is the same concept which we use in this network. If two branches are taking current, we need a return path. The return path will take the current from N2 to N1. The same concept here. If 3 ampere current is flowing from network N1 to network N2, there will be a 3 ampere current flowing from network N2 to network N1. So 3 ampere currents will be returning here. Right? Now, I am just, magnifying this part for you. This is point C. This is point D. Okay. So far we know the current from D to C is what? 3 amperes. Right? This is what we found out. This is what we found out, right? Now, this is 2 amperes and this is 1 ohm. Right? This is 1 ohm, this is 2 amperes, this is 3 amperes. Tell me if 2 amperes is coming from here, 3 amperes is coming from here, right? What will be the current in this branch? What will be the current in this branch? 2 amperes here, 3 amperes here. What will be the current here? Can I say 5 amperes? What is the concept applied here? KCL. 2 incoming currents, then the outgoing current could be what? 5 amperes, right? If this is 5 amperes, tell me what will be the polarity here? What did we learn? In the direction of current, we see a positive in, right? So this should be like this. So can I say VDC? Can I say VDC? Can I say VDC is equals to, what is the current flowing? 5 into 1 ohms. Can I say that? Right? So can I say 5 amperes, right? Can I say VDC is equals to 5 volt? But what was asked to you in the question? VCD. So what is VCD? Minus 5 volts. Easy question. So I am summarizing whatever we have learned in today's lecture. The first thing that we learned was in a balanced circuit, in a balanced bridge, there is no current flowing between, there is no current flowing between the middle branch. Why? Because point B and C would be at equipotential. Also, what did we learn? We learned that network redrawing technique helps us solve question, right? So we need to be, so that reduces our effort. In case you were not aware of network redrawing circuit and also not aware of what is balanced bridge, you would have approached this question using star delta transformation, which would have taken a lot of time. So you can save time here, right? The second thing that we learned was, again, this is the concept of equipotential points in case of a balanced bridge that we have mastered. This you need to remember that the impedance in case of capacitors is what? 1 upon j omega c. So the relation will not, you cannot utilize the relation as it is as in case of inductors. In case of capacitors, you'll find an inverse relation. Because why? Because impedance in itself is in inverse to the inverse relation to capacitance, right? So that you need to utilize. It was a easy question. Okay. Here we learned the concept of return path. So if branches are taking currents from a part of network to another part of network, there should be some branch which will bring back the same equal current to from N2 to N1, right? This is what we utilized in this question also. Okay. So tomorrow be prepared. Tomorrow we'll be taking a lecture on again miscellaneous, and we'll try and do questions on resistance cubes. We'll try and do questions on infinite resistance type in case in series of networks which are going till infinite, and some more some questions, general questions. I'll try and bring new questions of different sorts so that you have a, it will widen your thought process, right? I'll try and bring more questions, more variety of questions for you. Okay? Chalo, see you tomorrow, everyone.